Hey everyone, welcome back to the channel where we break down the latest in AI and tech. Today we are diving deep into a game-changing technology that's being quietly adopted by giants like Google, Microsoft and OpenAI. It's called MCP, Model Context Protocol. If you're building with AI, this is the standard you need to know. It's open source, model agnostic, and it could redefine how AI agents connect with the world. So what is MCP? How does it work? And why is everyone jumping on board? And what are the pros and cons? Let's unpack it all over the next few minutes. Let's start with the problem. If you ever tried to hook an AI model into external tools like Slack, Google Sheets, or even a SQL database, you know it's messy. You build a custom integration for each tool, often locked to one provider with brittle code and tons of overhead. Now you imagine this. What if there was one universal connector like the USB-C of AI that could let any model talk to any tool securely in real time? That's what MCP aims to solve. Instead of creating one-off bridges between every AI model and every tool, MCP standardizes how these connections are made. Think fewer bugs, faster development, and infinite scalability. So what is MCP? At its core, it's a standard protocol that lets AI models interact with external tools like APIs, databases, apps, and more in a secure and structured way. Now let us understand its architecture. Its architecture goes like this: MCP client, MCP server, communication, and discovery layer. MCP server is like an AI-powered app like Claude or ChatGPT. MCP server is the tool or services you want to connect to, like Google Drive, PostgreSQL, or Notion. Communication is like a JSON-based structured format for requests and responses. Discovery layer lets models ask what tools are available and how to use them dynamically. It's not just calling a function. It's like the AI model is browsing a toolbox in real time and asking, hey, what tools do I have? What can I do with them? Imagine playing an open world game where your character dynamically learns new tools and spells as they explore. That's MCP in the real AI world. Let's get into what MCP can actually do. These are some real world use cases being implemented today. In the business automation, you can pull customer records from a CRM, analyze them with the model, automatically send an email via Gmail or a Slack message. In the location-based services, you can ask Google Maps for the best cafes nearby, combine with Yelp reviews via an API, make a reservation through OpenTable. In developer tools, you can read GitHub issues, create a pull request using MCP, comment or merge automatically. In creative workshops, you can use a Blender MCP server to generate 3D assets, interface with Figma for design changes, export assets to Google Drive. Here's the twist. This isn't just a cool idea, it's becoming the industry standard. Google, OpenAI, Microsoft, Amazon, everybody are integrating this protocol in their organization. In Google, Gemini API and Gemini Pro now supports MCP. You can integrate with Maps, Workspace, YouTube APIs via a standard protocol. In OpenAI, the new Agents SDK supports MCP, allowing ChatGPT 4 to act as an agent and talk to third-party tools. Microsoft integrated MCP into Copilot Studio to let agents interact with tools like Outlook and Azure. Amazon supports MCP via QDeveloper CLI or CLE, letting agents query AWS services using MCP-like interaction. It's all about interoperability and avoiding the N-cross-M nightmare where every tool needs a unique integration for every model. MCP just simplifies this. Let's look at the builder's perspective. How do you actually implement MCP? Building a simple MCP server. You should install the Python SDK. It's also available in TypeScript and Rust. Define your tool schema. Implement tool actions such as fetch data from Notion, deploy locally or on server, register with your AI client like Claude or Gemini. You could literally write an MCP server for your database in under 20 minutes. And the best part, any MCP compliant model can use it like Claude, GPT-4 or Gemini. Now let us talk on pros of MCP. Simplified integration. Forget custom code per tool per model. MCP makes integrations modular and reusable. Dynamic discovery. AI models can ask what's available, not guess. That's next level flexibility. Vendor neutral. Don't get locked into one modular provider. MCP supports multi-model deployment. Community ecosystem. Over 1,000 open source MCP servers exist today, from GitHub to IoT devices. Enhanced AI functionality. Your AI doesn't just talk, it acts. Real world actions in real time. Coming to drawbacks and early challenges. Of course, no tech is perfect, especially in the early days. Let's cover the current limitations. Security. Open authorization was added in 2025, but early implementations used plain API keys. Prompt injection is still a threat. Adoption dependency. The more tools that support MCP, the better it gets. But not everyone's on board yet. Developer complexity. Building custom MCP servers for legacy or internal tools can be tough. Authorization, especially open authorization, can be tricky. Latency and performance. Remote MCP servers can be slow. For real-time apps, local servers might be better but consume resources. So what's next for a MCP? Marketplaces like mcpmarket.com and Pulse MCP are becoming hubs for pre-built servers. Expect even more support from companies across finance, health, education, and manufacturing. Soon you will see AI agents coordinating multi-step tasks across domains via MCP. The agent won't just summarize data, it'll update CRMs, run reports, and trigger alerts autonomously. So that's MCP, the universal adapter for AI integration. If you're building AI tools or agents, this is the protocol to learn. What are your thoughts on MCP? Are you excited, skeptical, or already building with it? Let me know in the comments. Like this video if it helped you in understanding the MCP. Subscribe for more deep dives into the tech shaping our future. Until next time, build smart, build open. See you soon.